I dropped my pencil. That's not good, is it? Hi guys, so today we're going to be going through 1H and it's mock set 1 and it's the Edexcel paper. If you want to access it, it's on the Google Classroom. The code is 6HUU7MT. So you'll be able to get it later on Google Classroom, and you'll find the Google Classroom on various previous TikToks. Okay. So here we've got the first question. You've got 2 and, hopefully this works, 2 3/5 minus 1 5/6. The easiest way to do it is you've got to first convert them into improper fractions. So top heavy fractions. So you're going to do 2 times 5 to give you 10. So you times that way, then you add it there. So you times and you add. So you're going to get 13 over 5 minus 1 times 6, giving you 6. You add it onto the top. So you get 11 over 6. Now you want to make the denominator the same. But the easiest way to do this is to use a butterfly if you can do the sums. So you're going to have 13 times 6 minus, so you've got 13 times 6 minus 11 times 5 over 5 times 6, which is 30. So you might know your 13 times table. If you don't, it's not a problem. You do 10 times 6, 3 times 6, and add them together, which gives you 78, minus 55, hopefully 11s are okay, over 30. Then we end up with 23 over 30. And that's your answer to question 1. Right, so question 2. So in question 2, we've got a graph, and it's telling you to give an interpretation. Now, they like these questions, especially as you then need to be able to use them when you do your, when you have when you do A-levels. So when you do A-levels, there's lots of interpretation-y sort of questions. So they've started to introduce them at GCSE. Now we know it's your plus C, but what does it mean? So now this question is all about phone calls, how much they cost. So this is saying, even if you use your phone for 0 minutes, you still have a certain amount of cost. So you have that Y cost. So that must be like your fixed charge for using the phone. So that's going to be your fixed charge. So we could call that your starting price. So that's the starting price on your phone. It then says, give an interpretation for the gradient. Now the gradient is the slope, and that tells you for every time you go 1x up, how many y's do you go up? So it's, in the case of a phone, it's every single minute that you use the phone, it's the cost that you pay. So the important thing is this is the cost per minute, right? So every time you've got a cost. Now your general interpretation for your gradient, if you're just thinking about it for any question, is for every additional, and then you'd have like x, whatever that is on your x-axis, the blah, so your y, whatever your y is, increases or decreases if you've got a negative gradient. Right, the next bit of the question asks you to find the equation of the line. I'm not going to scroll up so you can actually see the graph. So in order to do that, we need to know a line has the form y equals mx plus c. So we need to find the m, which is our gradient, and we have to find the plus c, which is where it crosses the axes. Now the plus c is easy, it crosses here, which is 0.5. And to find our gradient, we have to make ourselves a triangle. And it doesn't matter where you make that triangle, but make it easy. So I'm going to use that bit here because I've got 5 there. And I'm going to go all the way to my 0.5. So I'm going all the way down here. So here I've got going from 5 to 0.5. So that space is 4.5. And here I'm going from 0 to 3. So it's my change in y over my change in x, which will give me 1.5. So y equals 1.5x plus 0.5. Now you can leave that as fractions if you prefer writing things as fractions. Okay, next question. We've got a pentagon. So a pentagon, and we want to work out the area. So in order to work out this area, we're going to split it up. Remember, we don't have a calculator, so we're going to try and make it as easy as possible. I would actually split this up into 3 bits. So I've got 2 triangles and I've got a rectangle. Now the rectangle, super easy. I can do 8 times 3. 4 times 3. I've got 4 and 4 times 8. I'm losing my head, sorry. I'm looking at someone's question at the same time. So 4 times 8, let's start again. My rectangle is 4 times 8, which is 32. And in answer to the question, yes, in order to do the next bit, I'm going to have to find out, I know that this is halfway, so I know that this is 4, but I'm going to have to work out this height. And I will be using Pythagoras. So well done, whoever said that. So we've got 4 along, we've got 5 there. So I've got a right angle triangle. So in order to find this side here, using a squared plus b squared equals c squared, I'm going to have this side that I want. So x squared plus 4 squared equals 5 squared. So this side that I want is the square root of 5 squared minus 4 squared. Now, hopefully you may have recognized it as one of those special triangles, which is a 3, 4, 5 triangle. But if you didn't, not a problem. You'd have done 25 minus 16, which is 9, the square root of it, which is 3. So now we can work out the area for a triangle. So for a triangle, we've got half base times height. So we've got 3 times 4, which is 12, divided by 2, which is 6. And then this one is also 6. So if we add it all up, we've got 32 plus 6 plus 6, which gives us 44 centimeters squared. Right, question 5. Sorry, question 4 even. You can tell it's been a long day. All right. On Monday, Tarek travelled by train from Manchester to London. His train left Manchester at 8:35. It got to London at 11:05. So whenever I do these with times, I think the easiest way to think about it is just draw yourself sort of, say 8:35. Okay, so in 1 hour, it would be 9:35. So that's 1 hour. In 2 hours, it would be 10:35. And we don't want to go quite as far as 3 hours because we've got to get to 11:05. So I think how many more minutes would it take me to get to 11 o'clock? So 11 o'clock would take me 25 more minutes. And then I've got 11:05, which is another 5 minutes. So in total, it's going to take me 2 hours and 30 minutes. So the difference between these two is 2 hours and 30 minutes, or 2.5 hours. Okay. The train travelled an average speed of 110 miles per hour. Okay. On Wednesday, Gil travelled from Manchester to London. He also left at 8:35, but was diverted. The train had to travel an extra 37 minutes. It got to London at 11:35. Okay, so let's see how long it takes him to go from Manchester to London on Wednesday. So we've got left at 8:35, 1 hour, 9:35, then 10:35, then 11:35. So that was quite straightforward. We can see that in total was 3 hours. Okay, so we want to work out the difference between the average speed of Tarek's train and the average speed of Gil's train. So we already know the average speed of Tarek's train. We need to therefore work out the speed of Gil's train. So we first know speed is equal to distance over time. Now we know the time is 3, but we don't actually know the distance because we know it's diverted by 37 miles, but we need to use this information to find the distance from Manchester to London. So if speed is distance over time, distance is going to be your speed times time. So your speed is 110 and you're multiplying it by 2.5. So you're going to say 2 lots of 110, right, which gives you 220 plus 0.5 of it. So you've got 55. So altogether, our distance is 275 miles. So now, in order to find the speed here, we've got 275 miles plus the extra 37 divided by 3. I know these are quite like a lot of mental maths, but do lots of sums on the side if that's what you need to do. So 275 plus 37 is going to give you 312 divided by 3. So 312 divided by 3. 3's into 3 go once. 3's into, and then we've got 0, carry the 1. 3's into 12 go 4. So we get 104 miles per hour. We're still not finished. We want to find the difference. So we want the difference between 110 and 104, which is 6 miles per hour. So that's a lot of work for your 4 marks. So as you get to the higher paper, it just all gets a little bit trickier. All right. So question 5. So the diagram shows a rectangular wall. Frank is going to cover the wall with rectangular tiles. Each tile is 60 centimeters by 30 centimeters. Okay, so lots of information here. 3/5 of the tiles will be white, some will be green, the rest will be blue. Okay, the ratio of green to blue is 1 to 3. How many tiles will he need? Right. So we've got to think about how we're going to start this problem. So I'm going to say, okay, so I've got to cover the whole wall with tiles. So I could find the area of each tile, and I could have the area of the wall. Right, but I know the areas might help, but actually I've got to match it all up. So each side has to match up. So this 6, I need to match up 1 bits of it, and I've got to match up the 30s along the side. So I'm going to end up having lots of squares, right? So that's what I'm trying to do. So first of all, I'm going to move everything into the same units. 1.8 meters is going to be the same as 180 centimeters, and 6 meters is 600 centimeters. Now, hopefully you can see that's going to make your sums easy, because if we assume the 60s are along the bottom and the 180s are along the top, let's find out how many tiles we're going to need. So we're going to do 600 divided by 60, which gives me 10, and 180 divided by 30, which gives me 6. Okay, so we know we've got 10 along the bottom, but 6 along the top. So of course we're going to go with the higher amount. Okay, so now so the total number of tiles that I am going to have, so I've got 10 along the bottom, 6 along the top, so 10 times 6, that makes any sense. So I'm going to have 60 tiles in total. Now, 3/5 of these tiles are white. So if I'm going to work out 3/5, I'm going to divide by 5 and times by 3. So 60 divided by 5 times by 3 is going to give me 36, and these are going to be white. Right? So I've got 36 that are white. And then I know some are going to be blue and some are going to be green. So the rest are going to be blue and green. So that means 24 are blue and green. But now I need to split that 24 into the ratio 1 to 3. 1 plus 3 is 4. We're going to do 24 divided by 4, which gives us 6. So that tells us how many green tiles we're going to have. So that 24 is split into 6 green and 18 blue. So I know that's quite a long question, but you've got to think about it step by step. So your answer would be there are 36 white tiles, 6 green tiles, and 18 blue tiles. Okay. Let's have a look at the next question. It says, if Frank leaves gaps between the tiles, well, logically, if you have gaps, you need less tiles. So you'll need fewer tiles. Right, so another one with speed time. They clearly like these. Okay, I think that's the whole question. Okay, so you've got Ria left home at 1300. Okay, she drove for 30 minutes at constant speed of 40. So let's try fill in this diagram. So this is when she left home. She drove for 30 minutes at a constant speed. So this must take her to 1330. She then stopped for a break, which we can see because her distance is not changing. She then drove to the hospital at a constant speed. So that must be this, what this represents. So we know that 2 squares represents half an hour. So therefore this must be 2 o'clock. This must be 3 o'clock. And this must, this must be 2:30 and this must be 3 o'clock. So we're at 3 o'clock here. Then what happens? She was there for 30 minutes. So she's there for 2 squares. So she's at the hospital till 3:30. She then drove home at a constant speed of 32 miles per hour. Okay, so let's try to figure out where she's got to. She drove at 40 miles per hour to start with for 30 minutes. So that's saying in 1 hour, she goes 40 miles. So therefore in half an hour, she's only gone 20 miles. So now we can see that 1, 2, 3, 4 squares is 20. So we've got 1, 2, 3, 4 more squares. So we've got 40. Right, and now it's telling us, so she's starting at 40, she's that far away from home, and she drives home at a constant speed of 32 miles per hour. So that means in 1 hour, she's traveled 32. So 1 hour, she travels 32 miles. But we don't want 32, we want 40 miles. So 32 divided by what will give you, so we want to get 40. So we know 1 hour is 32. So we need another 8 miles. So what we're going to do is we're going to do 32 divided by, well, we've got to divide that by 4. So 1 hour divided by 4 will be 1/4 of an hour. So if you think about that in minutes, that's 15 minutes. So altogether, it takes her 1 hour and 15 minutes. So that's going to be, takes her till 4 o'clock, 4:30, and a bit more. So she's going to have to go all the way till here. So will she be home before 4:30? And the answer will be no. And you can show that by showing your graph. So you can show that 16:30 is here, and that would have got you the marks. So whenever you've got miles per hour, don't worry too much about your distance time formula. All 40 miles per hour means, it means in 1 hour, you go 40 miles. So in half an hour, you go half of that, and so on. You can keep halving things. And especially on a non-calculator, that should definitely work. So next one. We've got an estimate question. Now be generous with these. You can round these lots, right? Don't make 43.2 43. Make it 40. You're going to make it as easy as possible for you to work out. So we're going to round that to 40. 99, we're going to make 100. and 0.19, we're going to make 0.2. So now we've got on the top 40 times 10. So, and we're going to divide that by 0.2. So we've got 400 divided by 0.2. 400 divided by 2 would normally be 200. But because we're dividing by a smaller number, so in terms of the decimals, we're adding a 0. Remember, when you divide by something smaller, you get a bigger number. So if you're dividing by, so if you're sharing things with less people, you're always going to end up with a larger number. Okay, so that's our estimate. Right, we've got shape A is translated by a vector 4 minus 7 to make shape B. And then minus 3 minus 2. So how do I go in one jump? So essentially all we're saying is we're moving 4 along and then we're moving 3 back. So the net effect of doing that is we've gone 4 along and then we've minus 3 backwards. And then we've got, so what you could do is write it like this, where you're adding the vectors up, because that's what you're doing if you do one after the other. But if you want to understand it, you're going 7 down and then you're going 7 more down. So altogether, here we'll end up with 1 and here we'll end up with minus 9. So a single transformation means what would happen? So translated, 4 minus 7 means 4 along and 7 down. And then minus 3 minus 2 means minus 3 the opposite way and then 2 down. So you're saying you're doing it all in one go. Okay, question 9. Right. A company orders a number of bottles from a factory. The 8 machines in the factory can make all the bottles in 5 days. All the machines work at the same rate. Okay, so if we want to think about it, if we think as 8 times 5, we'll end up with 40 machine days. Okay, so that's how long it takes to make them. But for 2 days, only 4 of the machines are used to make the bottles. Okay. From the 3rd day, all 8 machines are used. Work out the total number of days taken to make all the bottles. Right. So if we think about it, for these 2 days, that's 4 times 2. So if you like, that's 8 machine days. So we need 40 in total. 40 take away 8 is going to give you 32. So we've got 32 days left. Right. But those 32 days, you've got 8 machines working. So if you do 32 divided by 8, we've got 4 days. So in total, you've got the 2 days that they started plus the extra 4 days. So your total is 2 plus 4, so 6 days. So that's the number of days to make all the bottles. So I'm translating it into machine days in order to be able to calculate these. It's a little bit strange, but you've got to really think about these questions, like what exactly are they asking? All right, let's have a look at the next one. All right, find the value of 64 to the power of, so we've got 64 to the power of minus 2 over 3. You see the minus sign and you think 1 over. So the minute I see a minus sign, I'm going to get rid of the minus by doing 1 over 64 and 2/3. Now, what does that mean? So if you remember your rules, something to the power is squaring it. So we can do that. But what does it mean if we've got, so remember we had a to the 1 over n. So that's the nth root of a. So if I had something to the half, it would mean the square root, and we don't normally write square root, we just normally write the sign. Something to the 3rd is the cube root. So what we've got here is we've got the cube root of 64 all squared. Now we could have done it the other way, but it's non-calculator, taking squaring such a big number and then trying to cube root it would not be easy. So let's take the cube root of 64, which will give us 4. And then we're going to square it, so we get 1 over 16. Right, question 11. So we've got some cumulative frequency graphs. I'm going to try and make this so you can see all on one page. And what you're doing is you're matching up the graph to the box plot. Okay, so if you want to imagine these, what you're saying is that's your smallest number on a box plot, that's your largest number. That's where the median is. So in terms of a cumulative frequency graph, if I go halfway here and I read this value off, this gives me the median. So for example, for A, I can see that the median is exactly halfway between 140 and 180. Because if I go along here and I go down, that's going to be my median for A. So hopefully you can see the one that matches that is this one over here. So you've got this Y here. So we know that A is going to match up to Y. Right, for B, if we take our median, we can see that the median for B is over here. So we're going to try compare the other medians to see where they are. So this one is to the left, so it's nearer 140. This one here is, so this one again is in the middle. Okay, so we have to decide, okay, so this could have been A or D. I just did the assumption, and this one's towards the end. Okay, so these B and C are easy to match up. B must match up with X and C must match up with Z. And it leaves me with D at W, but how would you know the difference between A and D? Which one matches with which? So if you have a look, the numbers are more spread out here. Can you see you've got more numbers here? So as you can see here, the numbers go out further. They're not all squished. Here you've got a tails at either end. So that's how you'd know the difference on that question. Okay, next one. Percentages. Okay, we love percentages. These are very easy ways to do percentages. So we'll show you how an easy way to do percentages. So in a sale, the price of a jacket is reduced. The normal price is 52. The sale price is 41.60. Work out the percentage reduction. That's the percentage decrease. Whenever you have percentage increase or decrease, you want to start off by finding the difference. So your formula is the difference divided by the original times 100. So no matter whether it's an increase or a decrease, you're looking at the difference, you're dividing it by the original cost and timesing it by 100. So let's see what's the difference. We've got 52 take away 41.60. So 52 take away, well, you could take, if you were to take away 42, you'd get 10, but you've then got to do that extra 40p, so you get £10.40. And then we want to divide that by 52 and times it by 100. Okay, so that doesn't necessarily look like the easiest thing to do without a calculator. But hopefully you're good at halving things. So if I halve 10 times 40, I'm going to get £5.20. I'm going to halve for 52. So when I halve 52, I get 26. And I can keep doing that. So if you're not good at doing, you can keep halving things until you can't halve it anymore. So that's going to become £2.60. 26 divided by 2 is going to give me 13. So, wait, so I've halved it £5.20. and 26, £2, okay. Yeah, £2.60 divided by 13. Okay, so now I know that 13 doubled gives me 26. So I know this goes in 2 times. So that's 1, that's going to be 0.2. Times it by 100 is going to give me 20%. So whenever you're doing things without a calculator, halve them, then divide them by 3 or divide them by 5. So get into the habit of being able to do your mental maths quite quickly. Right. This is proofs. Prove algebraically the difference. I think we did this question on a different lesson when we looked at looking at things algebraically. And so we're looking at odd numbers. So if you remember, whenever we're doing proofs and we see an even number, we're going to write 2n or 2m or 2 something. And an odd number is the even number plus 1. But we want 2 different odd numbers. So I'm going to have my let 2 odd numbers be. Now, what are they going to be? Be 2n plus 1, and let's say 2m plus 1. And what we want to do is we want the difference between them. So that means we're going to take them away. Minus 2n plus 1. And when we take them away, we're going to get 2m plus 1, and that's going to minus 1, minus 2n. I can take a 2 outside the bracket, and then we say is of the form 2 something, so 2x, therefore, those 3 dots means therefore even number. We don't need to write a big long essay, but because we can take 2 outside the bracket, it's definitely an even number. Okay. Now, we're coming towards the end, so coming towards the more trickier level 8 and 9 questions. Okay. So we've got, right, 0. So you've got 0.624 as a fraction. So if you remember how we start this, we're going to say let n equal 0.624. I'm going to multiply it by 10. And I've got 6.24. So this is the same as 242424. And essentially, remember, we wanted the same thing after the decimal place. So if we were to multiply it by another 10, we're not going to be able to do that because we're not going to be able to cancel it out. So I'm going to multiply that twice. So if I multiply that by 110 and another one, I'm going to get 624.242424. And I can see that after the decimal place, it's the same. So now I've called that 1 and 2, for example. If I do 2 take away 1, 1000n minus 10n is going to give me 990n. 624.242424 take away 6.2424. The 2 4s are going to disappear. And I'm going to get 624 take away 6, which is going to give me 618. And then to get n, I divide by that. Now, that is not in its simplest form. Now, hopefully you recognize, if you don't, it's fine, you could have done the halving thing, but you recognize that all these numbers go into 3. Now, another way to know that something always divides by 3 is if you to add up the digits separately, and if that divides by 3, a number divides by 3. So 6 plus 1 plus 8 is 15, which divides by 3, which tells you 618 divides by 3. 9 plus 9 gives you 18, which divides by 3. So you know that 990 divides by 3. So if I divide the top by 3, 6 divided by 3 gives me 2. 18 divided by 3 gives me 6, so I get 206. 9 divided by 3 is 3, so 330. Now those are both even, I'm going to half them. Half of 200 is 100. Half of 6 is 3, so I get 103 on the top. And half of 300 is 150. Half of 30 is 15. Add them together, and that's the simplest form that I can get. So whenever I'm doing those and I'm asked for the simplest form, you keep on dividing. Right, so now we've got a section of a vertical cross section of the center of a bowl, right? We can see it's a quadratic, so it's a smiley face if we were to continue it. And we want to find the depth of the bowl. Now, it's a really confusing way of saying, I want to find this minimum point. So I want to find out halfway between either of these. Now, I know one of these is 0. I want to find out what that is. How do I do that? Well, that's going to happen when y is 0. So 0 equals x squared over 10 minus 3x. If I wanted, I could times everything by 10. So I'll get 0 equals x squared minus 30x. I can take x outside the bracket. X minus 30 equals 0. X equals 0. X equals 30. So that's 30. So that means exactly halfway must be 15. So I've got the x coordinate for exactly halfway, and I want to find the y. So I'm going to substitute the 15 back into there. So y equals 15 squared over 10 minus 3 times 15. Okay, so we've got to these sorts of questions. I'm hoping that you've got this, but 15 squared. So whenever you're squaring something that ends in a 5, what you do is you take this and you times it by 1 more than that. So you times that by 2. So that becomes 2. Then you take your 5 and you square it. So 5 squared, which is 25. So 15 squared is 225. I'm not sure where the color changed. Divided by 10 minus 3x. So minus 3 times 15. So we've got 22.5 minus 15 times 3, which is 45, which we should be able to do. And we're expecting a negative number because it's below the axes. So it's minus 22.5. So therefore the depth of the bowl, so this is minus 22.5. So therefore the depth, we don't write minus 2.5. We would say the depth equals 22.5. Because we don't need to write the minus sign in because it's not asking us for the coordinate. It's asking us how deep it is. Okay. Question 16. Okay, evaluate Charlie's method. All right, we've got vectors here. Oh, they like these. They like you to say why it's wrong or right. So here we go. We have BM, so this point here, which is in this ratio. So hopefully you recognize that that's 1 plus 2, which is 3. So this bit is 1/3 and this bit is 2/3. And then you can instantly see his mistake because he's used 1/2 instead of 1/3. So when you evaluate his method, you say Charlie should have used 1/3, not 1/2. Because when you split that into a ratio, it's going to be 1/3, not a halfway. Okay, Martin expands this. Explain why Martin's solution can't be correct. This means you don't need to multiply everything. It must be something quite obvious. So it's either probably going to be the first lot of numbers or it's going to be the second lot of numbers. So if we take the first lot of numbers there, what have we got there? We have 2 times 2 is 4, times 3 is 12, so it's not the 12. Let's take the end. 1 times minus 3 is minus 3, times plus 2 is minus 6. There's only one mark, so I'm not trying to open the whole thing out. So we'll say the constant term should have been minus 6, not plus 6. Okay. Right, question 17. A, B, and D are points on the circumference of a circle. I know everyone hates circle theorems, but you guys have got this. It's not so bad. EDC is a tangent. Okay, circle theorems, I see a tangent. My head's going, okay, there's a right angle there. So I can see, I know that this is going to make a right angle. Angle BDC, so BDC is 57. So this angle is 57. And you want to find AOB. So the angle that we're looking for is this one here. Right, so let's go through what we know. So hopefully you can see, well, we can fill in what we know, but we also know that OAB, you see we've got, remember we have this weird Z that we can make inside a triangle. So if you've got OBA, with a circle, sorry, we can make that weird Z, which is your alternate segment theorem. So OBA is 57, and so is OAB, right? So OAB, so here, this angle here is also going to be 57. So we would write OAB equals 57 degrees because of the alternate segment. And if you're not sure about that, I will be doing a circle theorems video and going through that slowly, because that's the strangest bit, if you like, circle theorems. Now we know that this is a radius and this is a radius. So if that's 57, that must also be 57, because we've got base angles of an isosceles triangle. So we've got OBA, because remember the center one is 57, and that's base angles of an isosceles triangle. And that means we can find our one, because we've got AOB must be 180 minus 57 minus 57, which gives you 66, and that's angles in a triangle, add to 180. Okay, so circle theorems I know are tricky. Sorry if anyone's on my phone, I think my battery's running low. Circle theorems I know are quite tricky, but don't worry about it. Come back to it, learn them. The worst case, you know, they're 3-4 marks, you'll be able to get most of it. I know people get really, really caught up on it. Okay, so next one, 17. So there's, by the way, there's other ways you could have done that question, but we'll just go with what we've got here. So the diagram shows the first 10 sides. It's telling you it's an nth term sequence. Now, just because it's not given to you in a row, it's the same thing. So if you write them out, 1.5, 3, 5.5, 9, 13.5. Let's find our first differences. So our difference here is 1.5, 2.5, 3.5. So the first difference is not helpful. Second difference is 1, which straight away means it's an n squared. So do you remember, we take this number, we divide it by 2, and we get a half. So we know we're going to have a half n squared. And remember, your n is 1, 2, 3, 4, 5. Right, so 1 squared would be 1, times a half would be a half. And hopefully you can see straight away that that's just going to be adding 1 to give you 1.5. Now let's try the next one. 2 squared is 4, divided by 2 is 2. And then if you add 1, you get 3. So here we didn't have to do anything too complicated to try work out the next bit. So your sequence in this case is simply a half n squared plus 1. Right. The clue is also it was 3 marks. So I was pretty sure it didn't have lots and lots of steps. You'd need to go up to sort of 5 marks for that to happen. Okay, 19. Right, we've got a right angle triangle. I know those of you that have stuck through this, keep going. There's only 24 questions, so we're almost there. Right, we've got ABD is a right angle triangle. C is the point on BD. C is the point on BD, ACB is 90. We want to prove that the triangle ABD, so ABD is the big triangle, is similar to CBA. Okay, so hopefully now you've seen that, like I've highlighted it, you can see that one side is the same. So remember, if a side is the same, we're going to like straight away write that down. So I've gone over it twice because I've got two different colors there. So I can see that one side is the same for both of them, and so is one angle. So we've got an angle as well. So ABD and CBA. Okay, perfect. So ABC and ABD are the same angle as well. So let's do that. ABC equals ABD, and that's a common angle. So we've got an angle that's the same. CAD and ABD, CAB, so we've done that one. And we've got CAD and ACB. So we've got two lots of right angles there. So we've got a right angle here and we've got a right angle here. So we've got another angle that's the same. So we've got, let's get these the right way around if I write these out properly. So we're going to have ACB, so ACB, and that equals BAD, and these are both 90 degrees, right? So that's given. So that's a common angle, and we could have done the common side as well. But now, if we can find all three angles, that's perfect. So we've got two angles which are the same. This one here, this one. And so we want to prove the final angle is also the same. So this one is the same as this one, which makes sense because 180 minus 90 minus ABD must be the same as 180 minus 90 minus ADB, ABC even, sorry, God. So then we've got angle, angle, angle. Sorry, I'm working through this question for the first time with you guys. So we've got three angles. We could have done a side one as well. We could have an alternate solution, but I think this one is easier. You can see that all three angles are the same. Okay, 20. Solve algebraically. Right, so we've got simultaneous equations, but with squares in them. Now, whenever you have this, you're going to rearrange it to make the one without a square into something we can substitute. So the easiest thing to rearrange is the second equation. So we're going to rearrange 2 to make x equal 2y minus 3. And then we're going to sub this 2 into 1. So we're going to get 2y minus 3 squared plus y squared equals 18. So that's going to give you 4y squared minus 6y minus 6y plus 9 plus y squared equals 18. So that's going to give you 5y squared minus 12y plus 9, so minus 9, because you're going to bring the 18 over from the other side, equals 0. And you want to be able to factorize that. So in order to factorize that easily, we're going to give the 5 to the 9. So we're going to get y squared minus 12y. We're going to do your 9 times 5. So you're going to get 45 equals 0. Now, hopefully you can see that you're going to have 9 and so you want to end up with 12 So you're going to have 45, 5 and 12, I got that right, minus 12, it's 5. So you're going to have, if you're going to factorize this, you're going to have 1. So you're going to have 15 and 3. Yeah, that's right. So you're going to have minus 15 plus 3. And now you have to give the 5 back. So you're going to end up with 5y plus 3 and 5y minus 15. You can divide this one by 5. So you end up with 5y plus 3, y minus 3 equals 0. So y can be minus 3 over 5, or y is 3. And then you would simply substitute them back into this one in order to find the matching x values, which give you 3 and so you're going to have 3/5 minus 3/5 times 2 minus 3, which gives you, sorry, x is 3 and x equals minus 21 over 5. Sorry, I've squished that all in, but that's going to be 5 marks, could be up to 6 marks in the exam. So hopefully that makes sense. Sorry, I'm just rushing to try and make sure we get through this whole paper. Okay, surds, everyone's favorite, right? So we're going to have to rationalize the denominator. So we've got 3 plus root 2, 5 plus root 8. So we're going to make it 5 minus root 8. So we're multiplying the top and the bottom by 5 minus root 8. So let's open this all out. 3 times 5 to give us 15. And then we've got 3 times 5, we've got 3 times minus root 8, so minus 3 root 8, plus 5 root 2. Root 2 times root 8 gives us minus root 16, which is 4. And on the bottom, we're going to get the square of the first, because remember this is a difference of 2 squares. So we're going to have 5 squared, which is 25, minus root 8 squared, which is just 8, which is minus 8. So we can see where the 17 comes from. And on the top, we've got 15 minus 4 to give us the 11. But we want to write this in terms of root 2. So remember, root 8 is the same as 4 times 2. So root 4 times root 2, so 2 root 2. So we're going to have minus 3 times 2 to give you 6 lots of root 2, plus 5 lots of root 2, and then you've got your answer. And I like these because they always tell you what you should get. Right, 22. So we've got a graph, and we're going to write down the equation of graph A. So what's happened? All the x's are reflected. So here, if the x is minus 2, here it becomes plus 2. So we write that inside the bracket is the x's become minus 2. Right, next one. Compare the 2 graphs. This graph, the whole graph has moved up by 1. So what we've done is we've taken the gx and we've moved the whole thing up by 1. When it's the y's, it's on the outside. So these are nice, easy questions. Right, we've got cos x. Now, if you don't know, this is one which you just need to know. You need to know your graph of cos x, and this is going to be 118 minus 1. Right, 23. All right, on the home run now. 23. We've got a histogram. Now remember what a histogram is. A histogram is the area is proportional to the frequency. Okay, so the area is going to give us a frequency. We know that from 25 to 30, the there are 20 members. So this bit here is 20. So if I think about that, I'm like, well, how big is that? You probably can't see the squares, but on the bottom, I've got 2.5 squares. And going up, I've got, oh God, 2, 4, 5, 10, 15, 20, 25, 30, 35, 40 squares. So if I think about that, so if I've got 40 squares, that's 1, 2, 3, 4. Then if I do 4 times 2.5, I'm going to get 20. Yeah. That's going to give me 10, isn't it? Because or 25. No, that's right. Because that's going to be 5, not 20. Yeah, so 5 times 4 gives me 20. So then that must be 4 going up, and then I count the squares to make sure I get 1, 2, 3, 4. Okay, I've got that right. So now we've got the area. We can work out the area of each of those little boxes. So we've got 10 along here, and we've got 5, 6, 7, 0.7 along here. So 10 times 0.7, so that one's 7. Here I've got from 10 to 25, so I've got 15 times 2, so that's 30. Here from 30 to 50, I've got 20 times by 2.56. So 20 times 2.6 is going to give me 52. 50 to 80, I've got 30, and that's 1, 2, 3. 30 times 0.3 is 9. Okay, right. So now I've got all the different amounts. So I've had to use that first bit of information to get the axes right, and then I can work out the individual bits. So now one member is chosen at random. What's the probability it's more than 30? So more than 30 is going to be 52 plus 9. But because it's a probability, it has to be over everything. So it's going to be over 7 plus 30 plus 20 plus 52 plus 9. When I work that all out, I get 61 on the top, and on the bottom 37, 40, 180. And that would be my probability. Okay. We've got hopefully the very last question, because if I'm not mistaken, there were 24 questions. Yes. Right, there are 6 black counters and 4 white counters in bag A, and 7 black counters and 3 white counters in bag B. 5 black counters and 5 white counters in bag C. Bernie takes a counter from bag A. So he takes a counter from bag A and he puts it into B. Okay. He then takes one from B and he puts it into C. And we want to know that there are more black counters than white counters in bag C. Right. So if I'm going to pick a black counter from bag A and put it into bag, so at this, to start off, so we want to know that in the end, bag C ends up with more black counters. So what we're going to do is you could have a black counter from A. So from A, there's a black counter, followed by a black counter from B. So just say black from A, then followed by black from B, and then put into C. So that means C will end up with 2 more black counters. Or you could get a white from A, but then you'd have to take out a black from B, because otherwise C wouldn't have enough. So those are the only 2 things that can happen. So to get a black counter from A, there'll be 6 out of 10. And is times a black from B. So now we've put that black from A into B. So now B, instead of having 7 black counters, now has 8 black counters. Instead of having 10 in total, it's got 11. Or, which is a plus, so remember, and is times, or is plus. We can have a white from A, so that would be 4 out of 10. And now I've put that white counter into B, so now B has 11 counters, but there's still only 7 black counters. So when I work that out, I've got, so my common denominator is 110 plus 110 here. So I'm going to have my 6 times 8, which I know is 48. I've got 7 times 4, 28. I'm going to add them up, and I'm going to get 76 over 110. And now if I wanted to, I could cancel that down, but it doesn't say simplest form, but I could half the top, that's 38, and half the bottom and put it. So your answer would be 38, so let me make that clear, over 55. Right, for anyone who stayed for that whole thing, well done. It was quite a long paper. It's quite a tricky paper. The paper is currently in the Google Classroom. You can download it. I'll upload a mark scheme as well. I'll leave this. This is obviously recorded on YouTube. You can go through it once you've done it. I've gone through it quite quickly. So in total, you'd have a lot longer to do the paper. And we have been online for 58 minutes. So, you know, you'd have a lot longer. So it's, you know, you get an hour and a half. I've gone through it really quickly. I haven't really had a chance to make it look pretty, but I will put all the work step-by-step solutions up as well. So this is on YouTube. This is saved on YouTube. And you can then go back and watch it later on, hopefully when you've attempted it. This makes so much more sense once you've attempted it. Okay, I'll see you guys back on Monday to go through topics. We're going to be looking at more function topics, functions, some of the level 9 stuff, and some of the functional skills and foundation stuff. Okay, have a good weekend. Let me stop this.